For Algebra 11.3 notes, this is measures of central tendency, and we're going to talk a little bit about dispersion. So, how dispersed some numbers are. So, measures of central tendency are mean, median, and mode. Range is more going to have to do with how dispersed the numbers are. We'll get to that in a minute. So, let's take a look at a basketball player's statistics, actually two different basketball players' statistics, and you're going to pretend like you are an NBA coach or an owner, and you're going to decide which player you would rather have on your team. So here is that player's data. So player one in game one had this many points and assists, game 2 points and assists, game 3, game 4, game 5, and then here's player two. Points and assists in game 1, points and assists in game 2, game 3, game 4, game 5. So take just a minute to look at this and decide which basketball player would you more likely have on your team based on player one's statistics and player two's statistics. This question is always highly debatable. Every year when we teach this in algebra, we have kids who can totally justify player one and can totally justify player two. If I add total number of points, I think this player is 60 and this player has 75, which is a lot more points. So first you may be thinking, maybe player two. But if you look at assists, player one had 24, while player two only had, if I did the math right, I did this quick, 16. So the people are scoring off of this person's assists and they're making 60 points. But it probably, to be honest, this is a complete opinion question. This is why data is important. This is why it really is interesting, I think, at the very least, to be looking at different types of data. But I think in the end, if you are truly an NBA coach or owner, you're going to say, who do I need more? Do I already have a high scorer and I'd rather have somebody who's better at assists, or do I need somebody who's going to bring in more points because we've got a lot of good players who have a lot of good assists? So this is debatable, but I just really want you to see that different data can be arranged in different ways using mean, median, mode, and then here in a little bit we'll talk about range. So those are all measures of central tendency, finding the center, finding their average over the course of however many games maybe they play. An outlier, if you see an outlier, that would be a number that's totally outside of the data. I always use the example, if we went around this classroom right now and wrote down everybody's age, including mine, mine would definitely be the outlier because everyone's going to be in their teens, and then there's your teacher who's much older. So the outlier is always a piece of data that is much greater or could be much lower than most of the other values that are in the set. So I think you've learned mean, median, mode, and range before, but just to quickly review, the mean is when you add up all the data and then divide by the total number that are there. So that gives you your average. So the mean is really the average. The median, a lot of kids forget to line up the numbers in order. They have to be in order first from smallest to largest, and then you end up just chopping off the littlest, biggest, littlest, biggest, littlest, biggest until you get to the center number. So the median is actually the middle number, the middle value once you cross them all off from end to end and you come up with that middle number. The mode, the word mode starts off MO, and so does the word most. So the mode is the number that's there the most. So if you have a number that repeats several times more than others, the mode is going to be that one that's there the most. Okay, so we're going to look at some bowling scores. What are the mean, median, and mode of the bowling scores below? So here's bowler 1, 2, 3, 4, 5, 6, 7, 8, all of their scores, and they have already done it for you. To find the mean, they added up all their totals. They divided by 8 because that's how many bowlers there are, and they got a total of 122. To find the median, they first lined them up in order, so the smallest number came first. You list them, even if it's there multiple times, you list it multiple times. You go in order from the smallest number to the largest, and then you chop off the ends until you come up with that middle number. In this particular case, the middle number was 2 different numbers, so you had to add them and divide by 2 to actually find that center number for the median, and it was 111. And then the mode was the one that was there the most. And clearly 104, 104, 104 is there more than any other number. So the mode is 104. I forgot to underline that the mean was 122. Okay, there is an outlier though. I don't know if you guys noticed this, but 189, somebody bold a 189, that's much higher than 104, 104, 104, 109, 113, 117, and 136. So 189 is definitely an outlier. So this is a number that kind of skews the data. It makes it seem like the average is really good. In fact, this average is higher than everybody's number except 2. So it's not really a good representation. When you have an outlier, it kind of throws everything off. So speaking of which, because there is an outlier, the median would actually become the best measure to describe the scores. So if they said, oh yeah, how did these bowlers do? You wouldn't say, oh, well, our average was 122. That's a little skewed because that's higher than almost everybody's number. So instead you go with the 111, the median, because the outlier kind of threw off the average. So the best way to point out the best way to arrange the data is by looking at the median. That's the best, representation of the data. So let's look at our got it. They're saying, okay, so let's say we don't use the outlier. Let's say we take out 189 altogether. So let's say we take it completely out. If we take it out, what would be our new information? So it wants us to redo the mean, the median, and the mode without the outlier of 189 now, and then describe which one would best show it. So I would take 104 plus 117 plus 104, I'm just copying these numbers from up here, plus 136, I would not add 189 this time, plus 109, plus 113, plus 104, and instead of dividing by 8, I've only got 7 numbers in there now, so I would divide by 7. So I did this really quickly earlier. You might double check that my math is right on your calculator, but I got 787. And I'm dividing, remember, by only 7 bowlers this time. So that was about, it didn't come out exactly evenly, but if you use your calculator, 787 divided by 7 is about 112. So that completely changed our mean. From 122, it's now 112. And again, this is the mean. Okay, now let's check out the median. Remember, in order to find the median, your scores have to be in order from least to greatest. So I'm going to just copy these down again up here because they're already in order. So I've got 104, 104, we're not adding them, 104, 109, 113, 117, and 136. We're not putting 189 on there. So they're in order from least to greatest. We'll just chop off the ends. So take away smallest, largest, take away smallest, largest, take away smallest, largest. And that leaves us with a middle number of 109. Okay, so maybe that's not the best representation of data now, because actually our lowest number was 104. So 109 is really close to that. So if I said the best representation of data is 109, that's really not accurate because we had several people who had a lot more than that. And then we're going to do the mode. So mode is the one that's there the most often, and that would still be 104. All right, so the number that would best represent this data is going to be the mean. And I will tell you, it's almost always going to be the mean because the average best describes data unless there is an outlier. If there's an outlier, you're going to go with your median. But if there is not an outlier, like when we took this off, the mean is going to be the best representation of data. So the mean best represents or describes, I guess. I don't know if they said, yeah, they said describes. So best describes the data. And that's really because it's without an outlier. So I'm even going to put that just because it's your notes, without an outlier. So remember, if it has an outlier, the mean is not going to be good. The median would be better. But if it has an outlier, you're going to go with the median. If it does not, go with the mean. Okay, turn the page and let's really quickly talk about finding a data value. So this is something that I lived by in college. You might live by this in high school as well. Let's say your grades on 3 exams are 80, 93, and 91. What grade must you get on the next exam to get that A in the class? So let's say you're like, I don't know how much I need to study, but I know I want an A in the class. I know I want an average of a 90 after all 4, and my first 3 are 80, 93, and 91. What do I need to get on my 4th test? So here's how you'd set that up. Your previous scores added together plus X, and the reason we add an X is because that's your 4th test that you haven't taken yet. Divide to get the average by 4, because there are 4 tests you're talking about, and you want it to equal a 90. So you would first start by getting rid of this divided by 4. So we would multiply 4 on both sides. That gets you 360. Go ahead and combine all your like terms, which is 80, 93, and 91. That gets you 264, but you've still got your plus X here. And then last up, subtract 364 from both sides. X would equal 96. So you would need to get a 96 on your 4th test for you to have an average of a 90 in the class. So let's say you're doing this again, and your scores were 80, 93, and 91, just like they were up here. But this time, maybe you don't want an A in the class. Maybe you just want to have at least an 88 on all 4. So we're going to work it out to see what we would need on your 4th test to have an average of an 88 in the class. So here is part A. So you're going to add the 3 you know, which are 80 plus 93 plus 91 plus X. And remember, we do that because we're trying to see what we would need to get on that 4th test. Divided by 4, and this time we just need it to equal 88%. So we're not going for that A, we're not going for that 90, we're just going for at least an 88 in the class. So the first step you would do to solve this problem is get rid of that divided by 4. So I'm going to times 4 on both sides. That cancels my divided by 4 times 4. 80 plus 93 plus 91. I did this earlier. If I did the math right, double check me. I got 264. Bring down your plus X. 88 times 4 is 352. And then last step, to get X by itself, you're going to subtract the 264. So subtract 264. So on that last test, you would need to get an 88. So to get an 88, you would need an 88 on the last test. All right, here's my next question for you, though, on B. If 100 is the highest you can get, so they're not giving extra credit. If 100 is the highest possible score you could get, would it be possible to get a 92 overall for my average? The best way to do this is just to try it and see. Let's say we want to get 100. Let's say we get 100. Is it possible for my average score to go all the way up to 92? Let's just try it and see. We have an 80 plus a 93 plus a 91, and let's just say we got full points. We got 100% on the last one. We're going to divide by 4 and see what that equals. So 80 plus 93 plus 91 plus 100, if I did my math right, I got 364. Divided by 4 total tests that you've taken, that math comes out to be 91. So is it possible for you to raise your score to a 92? No, it is not. And the reason is because, how do we want to explain that? Because with your previous scores, and 100 on the next test, the highest possible score, average, we're going to change that word to average, the highest possible average is 91. So that is not possible for us to bring it up to a 92. Okay, last set of information is going to be the range. So I kind of saved this for last. It's really the easiest. The range helps us decide the measure of dispersion, how dispersed or how spread out. The word disperse means spread out, how spread out the data is. And so we're going to find the range to see how spread it out it is. The range is just all you do is you take the difference, so you subtract. the largest number and the smallest number. So literally you're just finding your biggest and smallest and subtracting. So here we go. The closing prices in dollars of 2 stocks for the first 5 days in February are shown below. What is the range? And then it says and the mean. And then we're going to compare. So for the range of stock A, we're going to take our largest number, which is 47, and then our smallest number, which is 25, and we're just going to subtract. So 47 minus 25, if I did those numbers right, it is 22. So 22 is the range. And then if I did the mean, I'm going to just add these together really quickly on my calculator here. I have 25 plus 30 plus 30 plus 47 plus 28. I'm going to divide it by how many are there, which is 5. And the mean is 32. All right, so we've got 22 and 32. Let's find stock B. So stock B, my range is my biggest number, which is 36, minus my smallest number, which looks like it's 28. So 36 minus 28 is 8. And then if I took the mean really quickly, I'm just going to add these up on my calculator real fast here. So I've got 34 plus 28 plus 31 plus 36 plus 31 again. That is 160 divided by 1, 2, 3, 4, 5 numbers. 160 divided by 5, that gives us a 32 for the mean. Okay, so this is why range is also important. The mean on both stock days is 32, but the range was hugely different. So there was a much wider range. The data was much more dispersed. In fact, that's what we're going to say to compare it. We're going to say stock A's closing prices are much more dispersed, are more dispersed. So since the range is bigger, that makes it more dispersed. There we go. And again, it's because its range is greater. Okay, if there's a greater range, that means the data is more dispersed. So stock A's closing prices are more dispersed, even though the mean is the same, the range is widely different. Okay, your last one, I have not shown you one of these line plots before. It's called a line plot where there's little X's. And so I really want you to look at this one. There's some line plots on your homework, but also a lot of times these pop up on the EOC, and you need to first understand them. So number of students in each homeroom class at Jefferson High School. So 19 students in the class. There are 4 classes that have exactly 19 students. That's what those X's above the line mean. Classrooms that have 20 students exactly, there are 5 at Jefferson High School. There are 6 classrooms that have 21, 2 classrooms that have 22, 2 classrooms that have 23, and 1 classroom has 24 students in it. So that's how to read a line plot. Your got it today is to try to find the mean, the median, and the range. So it didn't say mode, which I think is interesting, but we should talk about that. The mode would clearly be 21 because the mode is the one that's there the most. So most classrooms at this high school have 21 students, but instead it's just saying mean, median, and range of the data. So go ahead and push pause and try those on your own, and then I will definitely work them out with you since you have not seen a line plot yet before. Okay, so for the mean is going to take up the most space because that's a lot of numbers added and divided by how many are there. So I'm going to add 19 plus 19 plus 19 plus 19, or I'm going to take 19 4 times, plus 20 plus 20 plus 20 plus 20 plus 20, which is 20 5 times. And then I'm going to take 21 6 times. And then I'm going to take 22 twice, because there are 2 of those. And then I'm going to take 23 twice. And then I'm going to add 24, because there's only 1 of those. So I already did this in my calculator, because I know you probably paused the video and did it yourself too. And I got a total of 416. I hope I did that right. And I'm going to divide by 20. And the reason I'm dividing by 20 is because if you go through and count up how many X's there are, there should be exactly 20. So there are 20 classes at the high school. So we're dividing by 20. And it didn't come out exactly evenly, but it was close. It was like 20.8. So we're just going to say about 20.8. So on average, there are 20.8. Obviously, you can't have a 0.8 students, but that is what the average is, the mean of students in this high school in the homeroom classes. All right, the median. Oh, sorry, lost this here. The median is when you line them up in order and chop off the ends until you get to that center number. Since they're kind of already in order here, I'm just going to use these X's. So I'm going to chop off the lowest number, lowest, highest, 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 lowest, highest. Maybe this wasn't the best way to do it. Lowest, highest. And then you're going to get to where the center number is actually 21. So the median is 21, which I think is interesting because our mean was almost 21, was basically 21. And then it just wants to know the range. Range is when you take the largest minus the smallest. So I'm going to take 24 minus 19, which that is silly. That answer is 5, which is not a very good representation of data, but it does tell us how many how it's dispersed, how dispersed the data is. So here is our mean, median, and range of that data.